Picking up where we left off yesterday, we had found the area for this regular polygon, for this pentagon, but we hadn't yet found the perimeter. We had drawn this little triangle down here, and so then we took and redrew that triangle over here so that we could split it in half and kind of look at it close up. We had found out that the central angle here was 72 degrees, so when we redrew the triangle and we split it in half, we cut that angle in half. So instead of 72 degrees up at the top, that little half angle is now 36 degrees. And we are trying to find this value right here, the size of this piece of the triangle. I know that that will be exactly the same as this because again, we cut the triangle exactly in half. So those two pieces will be the same size. And once we have those two, when we put them together, that gives us the side of the pentagon. So, do you guys remember when we did sine, cosine, and tangent, SOHCAHTOA? That's what we're going to use to find that missing side. So SOHCAHTOA, we're going to stand up at this 36-degree angle. And then we're going to label our sides. I'm just looking at that blue highlighted triangle. What would be the hypotenuse of that blue highlighted triangle? 4 would be the hypotenuse. The side that we're looking for down here, would that be opposite or adjacent? Opposite, because you have to go from where we're standing up at that 36-degree angle, you have to go through the triangle to get to the opposite side. So there's our opposite. And we're not interested in the adjacent side, so I'm not even going to bother labeling it. So I want you to look over here at SOHCAHTOA. Which of those, so, ka, or toa, are we going to be looking at if we have the hypotenuse and we want the opposite? Which one of those use hypotenuse and opposite? Sine. The O stands for opposite, the H stands for hypotenuse. We're not interested in the adjacent side, so it's not going to be cosine. We're not interested in the adjacent side, so it can't be tangent. All right, so that is our sine function. Sine of the angle is equal to opposite over hypotenuse. So I have sine of, what's my angle? 36 degrees. Sine of 36 degrees equals opposite. We don't know how big the opposite side is, so I'm just going to write opposite, or OPP for opposite, over the hypotenuse, and the hypotenuse is 4. Now, what do I need to do to get the opposite side all by itself? Well, right now it's being divided. If I divide, dividing doesn't undo dividing. Multiply 4. Remember, whenever we have a fraction that we want to get rid of, you always multiply by the bottom. In this case, the bottom is the 4, so we're going to multiply both sides by 4. We can't do anything with the 36 because 36 has an operation. It has sign attached to it. You can't add, subtract, multiply, or divide with that 36. It is trapped inside of a function, inside of that sine function. All right, so we need to do 4 times the sine of 36 degrees. What do we get? If you guys don't have a calculator, please come and get one. Yes. 2.351 is equal to the opposite side. So this is 2.351. This right here would also be 2.351. So we're going to take that 2.351, we're going to times that by 2. What do you get if you times that by 2? Yep, 4.7 or 4.702, right? That is equal to the side of the pentagon. And now we're going to find the perimeter. Perimeter for a regular polygon is equal to the number of sides times the length of each side. How many sides does my pentagon have? 5. Times the length of each side, that's what we just found there with that 4.702. What is 5 times 4.702? 23.51. Should we put units with that? Nope, we didn't have any units in the problem, but you can always write the word units next to it. If you didn't have anything there because they didn't give any units in the problem, that would be okay. I'm not going to take off any points for something like that. Nicely done. Very nicely done. All right. Let's go down and look at problem number 4. And guys, while we're switching problems, if you don't have a yellow calculator or something that you can use like a yellow calculator, please go and get one right now. All right, now we are ready to start on problem number 4. It says sketch a regular octagon with a radius of 8.4 inches, then find its perimeter and area. I am not super great with drawing these figures, but I'm going to give it my best shot. An octagon has how many sides? 8 sides. So I want to draw an 8-sided figure. Should look like a stop sign. All right, I got 4 sides. 5, 6, 7, and 8. So something like this. It's far from perfect, but that's my best shot. All right, a radius goes from where to where? On a polygon. A radius goes from where to where on a polygon? From the center to the vertex. So from the center out to one of the corners, I'm going to draw in a radius. That radius is 8.4 inches. If we are going to find the area or the perimeter, I need to make a little triangle. Whenever they give me the radius, I need to make a little triangle. So I need to draw in another radius over here. And that other radius will be exactly the same size as the first one. So this will also be 8.4 inches. The whole reason I'm doing this is the area formula when we've been given the radius is 1/2 AB times the sine of angle C times the number of sides. The radii go in for A and for B, so those are going to be the same. Those will both be 8.4. So 8.4 for A, 8.4 for B. Then we have the 1/2 out in front. And then we have sine of angle C. So we're going to need to find this central angle, the angle in between my two radii. All right, so the central angle. How do we find the measure of the central angle again? 360 divided by the number of sides, divided by n. So we're going to do 360 divided by what?
8.
360 divided by 8. What is 360 divided by 8? 45. So this angle here is 45 degrees. So that's what we're going to put in for angle C, 45 degrees. And then we have to multiply that by the number of sides, so we're going to times that all by 8. I would like for you guys to put just this much right here into your calculators first. What is 1/2 times 8.4 times 8.4? You said 35.28? 35.28 times the sine of 45 degrees times 8. So let's pop that into your calculator. What do we get for the area? You said 199? Yes, 199.573. 574, depending on how you round. Should we put units with that? Yes. Inches? Inches squared because it's area. Nicely done. Okay, so we found the area. We still need the perimeter. So to do the perimeter, we're going to redraw that triangle that we had made inside the octagon. I know that each of the radii are 8.4 inches. We are going to split that triangle in half vertically. Makes a right angle over here. We are looking for this piece right here. And we are going to stand up here, but I need to know how big that angle is. How do I find the angle, the size of the half angle there that I'm standing at? This angle right here. What'd you say? Divide by 2. We're going to take the 45-degree central angle, and we're going to divide it by 2. What is half of 45? 22.5. Again, this is half of the central angle. So down here where we found the measure of the central angle as 45 degrees, right here, this is the triangle that we've redrawn over here. And we cut that angle in half, so now we just figured out that that is 22.5 degrees right there. I don't have enough room to like write it in the triangle, so I'm just going to arrow over. And now I need to label the sides of my triangle because we're going to do SOHCAHTOA again. The 8.4 right here, is that adjacent, hypotenuse, or opposite? That's the hypotenuse. The side that we're looking for, is that adjacent or opposite? Adjacent has to be touching my angle. Is it touching the angle that we're standing at? Nope, it's opposite because you have to go through the triangle to get there. That is my opposite side. So sine, cosine, or tangent? Sine, because that's the one that uses opposite and hypotenuse. We don't care and don't know about the adjacent side. All right, so we have sine of the angle is equal to opposite over hypotenuse. So that would be sine of what? 22.5 equals, what do we put in for opposite? Just opposite, absolutely correct. That's the thing we're looking for. So that's my variable, that's my unknown. Over, what's the hypotenuse? 8.4. I want to get the opposite side alone. Opposite is part of a fraction right now. How do I get it by itself? We're going to multiply both sides by 8.4. Cancels out there. So I have 8.4 times the sine of 22.5. And what does that give me? 3.214 for the opposite. That's only giving me from here over. That's this 3.214. I need that whole side. So what do I need to do to this 3.214 to get the whole thing? Multiply it by 2. So times that by 2. And that would be how much? 6.428. This is my side. So I'm going to come over here and actually add that onto my picture. 6.428. And now I can find the perimeter, because the perimeter is equal to the number of sides times the length of each side. How many sides do we have? 8 sides times 6.428. What is 8 times 6.428? I'm sorry, I could not hear. 51.424. Should we put units with that? What units? Inches. Beautiful. All right. Let's go look at number 5. This time it says we have a regular decagon, and then they've drawn it for us. A decagon has how many sides? I didn't hear what you said first. 10. Yes. A decagon has 10 sides. 9 sides would be a nonagon. Has a radius of 15.1 meters. A radius goes from the center to a vertex, center to a corner. So I'm going to draw one in. And because they've given me the radius, let me write that in here, 15.1. I know I'm going to have to draw in another radius. So that will also be 15.1. Because the area formula for a regular polygon when we've been given the radius is 1/2 AB times the sine of angle C times the number of sides. What are we putting in for A and for B? 15.1. We've got that 1/2 out in front before the parentheses. All right, then we have times the sine of angle C. Angle C is my central angle. How do I find the measure of the central angle? 360 divided by the number of sides, which in this case is 10. So 360 divided by 10. What is 360 divided by 10? 36. So this angle right here is 36 degrees. So sine of 36 degrees times 10, because we have 10 sides. All right. Let's pop that into your calculator. What do we get? The sides are 15.1. You shouldn't get something as small as 19. Yep, what's the whole thing? Oh, did you just do that one part where it's like the 15.1 times 15.1 times 1/2? Or did you do the whole thing? Okay, well, I'll come back there and look and see how it got put in to see what went wrong. 670.104. What units should we put with that? Meters squared, yes. Nicely done. All right, we still need the perimeter. So how do I start that? Redraw the triangle. We're going to redraw the triangle from over there. I know that this side is 15.1 meters. This side over here is 15.1 meters. We are going to draw a line straight down through the center of that triangle, splitting that top angle in half. So how big will that top angle be now that it's been split in half? 18. 36 degrees divided by 2 is 18 degrees. That's how big we are here. This is where we're going to stand. We're looking for this. The side that we're looking for is which side? The opposite side. The 15.1 right here is which side? That's the hypotenuse. So sine, cosine, or tangent? Sine. Sine of 18 degrees equals opposite over 15.1. I'm actually going to scoot that down here because I kind of ran out of room. So now what do? Multiply both sides by 15.1. That's going to cancel out. So what is 15.1 times the sine of 18 degrees? There's 3 6s? So 667, something like that? You can do 4.666, 4.667. I'd take either one. There's my opposite side. Oh, it's 4.6661, so we should have 4.666. My apologies. I thought it was just a 6 repeating. My apologies. 4.666 for the opposite side. But that's not the whole side of my decagon. What do I need to do to that now to get the side? Multiply it by 2. So that gives us what? 9.332. There's the side. And now the perimeter is equal to the number of sides times the length of each side. So I have 10 times 9.332. What does that give me? 93.32. What kind of units? Meters. Very, very nicely done. All right. All right. Let's look at one more. Number 6. Find the area and perimeter of the regular polygon. All right, so my first question looking at this is, what have they given us? They gave us an 11. Is that a radius? Is that an apothem? What is that 11? It's a side length. Well, if they gave me the side length, what would be the easiest thing for me to find first? The perimeter. Perimeter is equal to the number of sides times the length of each side. How many sides does this shape have? How many sides do we have? 7 sides. 7 sides times the length of each side, which is 11. What is 7 times 11? 77 units. Yards. All right, we found our perimeter. We don't have a radius or an apothem, do we? No. So we could find either one of these. So my question to you is, which one of these area formulas do you guys want to use? We can decide here since we don't have a radius or an apothem. So we can use 1/2 AB sine C times N, like we've been practicing with, or the other area formula that we had, area equals 1/2 apothem times perimeter. We know the perimeter, so that might be an easy one to use. We don't have the radius. We don't have the central angle. Which one do you guys want to use here? Second one. So we can use this one, but we're going to have to go in and find the apothem now. That is what that line is. We just don't know how big it is. We have to have its size. So this right here is the apothem. The apothem is actually, when we've been redrawing our triangles off to the side and then splitting them in half, when we split them in half, what we've been drawing in is the apothem. We just haven't been finding it. So there's the apothem. I'm still going to have to create a triangle here. I know that the apothem makes a right angle where it hits the opposite side. I know how big this side is. How big is that whole side down there? That whole thing is 11. But I want just this much of it. How much of the 11 is that? 5.5. It's exactly half. So this much right here would be 5.5, because this part over here would also be 5.5. So far, so good? All right, I'm going to redraw that triangle that I have highlighted off to the side so that I can look at it a little bit easier. So down here is 5.5. This is the apothem. I know we have a right angle right here. I need to know this angle so that I can use SOHCAHTOA to find my apothem. Well, I know how to find the central angle. And when we've redrawn these triangles with the apothem as one side and a radius as another side, we've been taking our central angle and then cutting it in half. So let's find that central angle. Measurement of the central angle is equal to 360 divided by the number of sides. So we've got 360 divided by what? Divided by 7. This is not going to come out pretty, but that's okay. We're just going to have to deal with some decimals. 51.428. And so to find this angle up here, we're going to take 51.428 and we're going to cut that in half. What is half of 51.428? 25.714. That is this angle right here where we are going to stand. All right. I'm standing right up here. This 5.5 down here is which side? Adjacent, opposite, or hypotenuse? Yes, this down here is the opposite. Is the apothem the hypotenuse or the adjacent side? This is the adjacent side. So let's look at SOHCAHTOA. Which side do we not have and we don't care about? Hypotenuse. The apothem is my adjacent side, and I do care about that because that's what I want. I don't have the hypotenuse, and I'm not trying to find the hypotenuse, so I'm not going to use sine. I'm not going to use cosine. We're going to use tangent this time. So we have tangent of the angle equals opposite over adjacent. So tangent of 25.714 degrees equals, what do I put in for the opposite side? 5.5 over my apothem. Interesting. I have 5.5 in my numerator. I have the apothem in the denominator. What do I need to do to get the apothem out of the denominator? Multiply. We're going to multiply by the apothem. So it cancels out over there. So I have apothem times the tangent of 25.714 equals 5.5. What else do I need to do now to get the apothem all by itself? I want this alone. Yes, we're going to divide by tangent of 25.714. If you do it to one side, you got to do it to the other side. And so that means the apothem would be equal to what? How much? Let me see what you typed in. You forgot the tangent part. Remember, we're not just dividing by the number, we're dividing by the tangent of the number. The number can't be separated from the tangent. Have to have the tangent next to it. 11.421, yes. All right, so here's my apothem. Now I can come up here and use this 1/2 AP formula. So the area is equal to 1/2 times that apothem that we just found, 11.421, times, what was our perimeter? 77. So 1/2 times 11.421 times 77 gives us what for the area? 439.708. Should we put units with that? What units? Yards. Squared. Yes, there we go. Yards squared. Very nicely done. So homework is not due until next Wednesday, but you guys do have your first skills check tomorrow. The skills check will be everything through page 5 in your notes. So it would be a good idea to start on that homework and practice with some of these area problems, especially ones where you have the radius and you have to find the area and the perimeter. So where we had to do the SOHCAHTOA. Problems like 3, 4, and 5 I would look at very closely, along with everything that we did on homework number 1 with the area for rhombuses, trapezoids, kites, and parallelograms. All right? Homework is due Wednesday. Oh, one more thing about the homework. I apologize. I was looking at it yesterday, and there's a problem that I've decided to cut off of the homework. If you guys pull that homework out for me real quick, I'll tell you which problem you're not going to do. It's on the back side. Problem number 13. Problem number 13 you are not responsible for doing, and you can cross that one out. Yeah, give me a second.